guys, welcome back to my channel. So today's my topic is principal components analysis. So before going to the topic of principal components analysis, we must know that what is a difference waveform. You all know I already covered this, what is a difference waveform. Still I will just tell you all. So we know that sometimes we need to detect whether one response is different from another. Difference by the name itself is telling that difference. So you first line you can see here, sometimes we need to detect whether one response is different from another. How to know that? The most common example is mismatch negativity. You can see in this diagram mismatch negativity. In this two waveform they are seeing that is it a significantly difference is seen. If the significantly difference is seen in these two recording, how much significant? So you can see here little bit difference, here more difference. So overall you have to draw the amplitude. That is called mismatch negativity. Here you can see the example also that difference waveform is 1032, which is first wave is 1032 hertz and second wave is 1000 hertz. So here difference waveform what they did 1032 minus 100,000 hertz, sorry, this will give the difference waveform. Okay, so this is the difference waveform. Now coming to the point, to the principal component analysis. We should know what is a scalp topography. So go with the point. Auditory evoked potential can be recorded from different location on the scalp. Yes, surely. We know that auditory evoked potential are recorded from different location on the scalp like CZ or then A1, A2. We know that, correct? And you can see with this diagram also. I will show you this diagram. So you can see this diagram. And from parietal, temporal, all these are the area of the scalp. So here you can place the electrode here. Here you can place the electrode in A1, is A2, CZ, then in frontal area. So same thing they are telling. So auditory evoked potential can be recorded from different location on the scalp. Many early potential means ABR waveforms, are generated in a single region of a brain that are maximally recorded using a single channel, measuring the difference between the two locations on the scalp. Okay, understanding this is very easy line. I don't have need to explain on it. However, as the latency increases means we are talking about mid latency response, late latency response, LLR, MLR. Okay. So latency increases, many different regions of the brain become simultaneously active. Okay. So here when we are recording the auditory evoked potential, only the sum of the region getting activated. Okay. But when we are prolonging the latency, the more area of the brain is getting simultaneously activated. Okay. Z, CZ, PZ, OZ, occipital, parietal, central, frontal, like that. Okay. So again once more, a method for linear decomposing a multivariate data matrix into a set of component. Okay, into a set of component. Please understand this line, what it is telling. Into a set of component. For example, I will tell with this diagram. Can I consider that this is the some set of component, this is some set of component. For example, I am giving this is some set of component and this is some set of component. So like that they are telling that, again come to the point, PCA is a method for linear decomposing a multivariate data matrix into a set of component, each of which explain a portion of variance in a data. Understanding? For example, if I consider this is the portion, one variance, multivariant is there na, one portion. This is another portion, this is another portion, this is another portion. Okay. So this portion I will calculate this, all this don't see all the parameters, okay, don't see all the waveforms. Just think that this much was only our waveform, this frontal area. Okay, now this frontal area overall, can we calculate and make it into one waveform? Only this much, if we are calculating, can we make it into one waveform? Yeah, correct. Can we again take another component in one waveform here, another one wave, two wave, four wave, like that? Can we make it into small, this complicated waveform, can we make it into small sections? Okay, this is no need so much to go. So now what they are telling in this butterfly and root mean square plots, what they are telling on this. So please see this. Just they are telling the all the waveforms, 65 channels, all these waveforms are just superimposed in each other, and they form some type of graph. This superimposed plot is called butterfly. You can see like a butterfly, it's looking now. So it's like a butterfly, so they put as a butterfly square, butterfly plot. Okay, and the root mean square amplitude of each time point is plotted, and each point, for this point P1, root mean square the amplitude they calculated, here amplitude they calculated, for this amplitude they calculated, here SP is this and this, nothing else. Just butterfly and root mean square plots are important to know for this scalp topography. So I put in this slide. We already know that principal component analysis is a method for linear decomposing a multivariate data matrix into the set of components. So these are the components, set of component they distributed. Okay, each of which explain the portion of variance. This will explain the portion of variance, 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 and this will explain the portion of variance. Understanding, which I have drawn the diagram before now? Same thing. This diagram I drawn, same thing. Okay, this, for example, you think this is this portion, like that. Okay, but in our tree evoked, they are mostly focusing on the temporal region. Okay, they are telling the first component reverse polarity over the Sylvian feature, being positive at the vertex and negative at the mastoid, being positive at the vertex and negative at the mastoid. Okay. The first component analyzes polarity over the Sylvian feature, being positive at the vertex and negative at the mastoid. Okay, now going to the second component, what they are telling in the second component, that is negative above the eyes and positive below, negative above the eyes and positive which is below. And the third component is positive anteriorly. Okay, sorry, this diagram, third component, positive anteriorly and negative posteriorly. Okay, done. Then fourth component has a topography that is negative over the left anterior, negative over the left anterior. Okay, and the positive on the right. This is likely a result of lateral eye movement. Okay, and the fifth component is maximally peaked over the mid-temporal. Okay, mid-temporal. Okay, which is recorded from T8 and T9. You can see here in this diagram, T8 and T9 will, T8 will come this side and T9 will come this side. Okay, T8 and T9, all these are component. These are a principal component analysis. So little bit easy, I know that this topic is very complex, but at least you understood some of the gross idea about principal component analysis, what is happening grossly. Okay, this will be helpful for your examinations. Welcome back again to my channel for another videos.